So in this tutorial, we're looking at evaluating functions, and the TI calculator can handle those fairly easily. And you'll see here that we're looking at two transcendental functions, so they're not algebraic in nature. Right, one's a log, a common log, and the other is a trig function. All right, so what I'm going to do first is I'm going to type that information into my calculator. All right, so y equals, in y1, I'm going to put my f, so I'll use the common log, and I'll type in a negative 5x. All right, rules of logs, in terms of the domain, we know that we can't have a negative contained within a log, so that means that our x values have to themselves be negative in order to make a positive or something greater than 0 the subject of the log. All right, so we'll keep that in mind, but it shouldn't matter based off of the information that we have here. All right, so then 3 times the sine of x. Now just kind of sneaking a peek at some of the questions here, I see that the g functions have 0, pi over 2, and so that's telling me that I should be in Radian mode. All right, so I go to mode, and I just make sure that instead of saying degree, it says radian. All right, while I'm at it, I also take a look at some of the other settings and make sure, because it is important when you're dealing with statistical concepts, that your stat diagnostics are on and your stat wizards are on. All right, so if those are set, then you have a pretty good mode and you're ready to go. And generally we want math print rather than classic, but there are some circumstances where we would want classic, but we'll cross that bridge down the line. All right, so second mode to quit out of there. So again, my equations are typed in. Now I want to evaluate. All right, so the first thing I'm going to note just on paper here is that I stored this into y1 and I stored this one into y2. So what I'm going to do to find the value of f of negative 2 is tell the calculator to compute y1 of negative 2. All right, so the way it does that, if I go back into my home screen, if I hit alpha trace, you see my list of y characters come up. All right, so alpha trace. All right, select y1. Open a set of parentheses. Type in the negative 2. All right, and once you do that and hit enter, it will evaluate the function log negative 5x, where x is equal to negative 2. So it's going to find the log of 10. All right, log base 10 of 10 should be equal to 1. So let's see. And there it is. All right, so very good. We now have a technique that we know will work. You could also use the table. That's kind of a less elegant way of doing it, but it's still a possibility if that's something you're familiar with. The only issue with the table approach is if you start getting into funkier values, it's not always going to be the most convenient way to go, but it's still an option. All right, so for B, I would be looking at y2 of 0. Again, alpha trace. So alpha trace option y2. Now, something to bear in mind, if you have a TI-84, you hit alpha trace all day long, nothing like this is showing up. All right, so on a TI-84, you need to hit vars, yvars, function, and then you'll have your list of all the stuff, y1 through y0. All right, I'll show that in a second. All right, so y2 of 0, if I plug in a 0 for sine of 0 is equal to 0, times 3 should be equal to 0. Let's see. And there it is. All right. So again, if you didn't have the alpha trace option because you have a TI-84, you'd hit vars, you'd go over to yvars, then you'd select function. Oops, didn't have to hit the down arrow. And then you see all your y stuff. All right. F2 minus g of pi over 2. So we really want y1 of 2 minus y2 of pi over 2. All right, so alpha trace y1 of 2, of 2 minus alpha trace y2 of pi over 2. All right. If I plug in a 2 for x, all right, so just kind of play this out logically, all right, because it's a piece at a time, but you still need to have something that's going to exist when you make a substitution. All right, so if I plug in a 2 for x, I'm going to get log of negative 10. All right, can't take the log of a negative number. It's outside of the domain. So this should give us a break. We'll see. All right, sine of pi over 2 is equal to 1 times 3 is 3, but it's going to be we're going to be looking at something that doesn't exist minus 3, which still itself should not exist. Answer non-real, error non-real answer. All right, so we know for this one we should have no solution. Now for the last one, this is a composite function. All right, so this is a function plugged into another function. First probably learned about that in Algebra 2. It wasn't easy then when you were getting your hands around this concept, but the calculator can handle this pretty easily. All right, so we'll quit out of this. All you would be doing is just following the notation. F, we are using y1 instead of an f, of y2 of pi over 2. So alpha trace y1 of alpha trace y2 of pi over 2. Close them up. All right, now if I plug in a pi over 2 to the sine function, sine of pi over 2 is 1 times 3 is 3. All right, that's a positive 3. So we're kind of looking at an issue here where, again, if I plug a positive number in for x into that log function, it should give me an error. All right, so let's see if that plays out. Error, non-real answer. All right. The moral of the story, or really one of the morals of the story here, is sometimes there is no solution, but you did everything right. All right. So just because you see an error on the TI calculator doesn't mean you did something wrong. Honestly, I would say that the only error on the TI calculator that means that you did something wrong would be syntax. If you get error non-real answer, if you get error divide by 0, so the undefined one, that could just mean that there's no solution. It could also mean that you did something wrong, but generally it means that there's no solution.